Hello, this is Mike at GameFromScratch, and welcome back to our ongoing MonoGame tutorial series. Now that we have the application lifecycle and event loop out of the way, today we're going to get into some of the slightly more fun stuff. That is loading in texture and drawing it up on screen. It's a pretty involved topic, actually. It sounds very simple, but there's quite a bit to it when you're working with MonoGame. It's not complex, don't worry about that, but there is a lot for us to cover, so let's jump right on in. Again, I assume you've seen all of the prior tutorials in the series, or you already know the content matter, so if I talk about something we haven't discussed already, please make sure you go back through the previous tutorials. Also, there is already published a text-based version of what we're about to cover in this tutorial. Just head on over to GameFromScratch.com, go to Tutorials, MonoGame, and the one on this one is particularly called Textures and SpriteBatch, and that's exactly what we're going to cover here. I'm also going to use the term sprite a lot, and sprite is a bit of a misnomer when dealing with MonoGame because there's no such thing as a sprite, technically, although there is a SpriteBatch, which always struck me as a very odd naming conflict from Microsoft. But historically, a sprite is a moving pixel texture. That's pretty much the definition of it. It's something that was on screen that could move around. And it used to be way back in the when days, back when you were talking about like the Atari 2600 type stuff. They used to have sprites built into the hardware. So you could have a fixed background and then 3 or 4 or 5 or 6 moving sprites that had special hardware that drew them on screen. Well, we've moved well past that stage. We're not even dealing with pixels anymore when we're talking about hardware. It's all textures now. But the term sticks with us. So now it's basically just a texture and position. And those two things go together to make what we'd call a sprite. Now, as I said earlier, there isn't technically a sprite class built into XNA or MonoGame. It's one of those things you roll your own. There is, however, a texture, and then what you normally do is have a corresponding value like vector2 for its position. And those two things go together, can be generated into a sprite class. So when I say sprite, I'm basically talking about a texture drawn at a position. So if you go looking in the documentation, you can't find out what I'm talking about. That's exactly what I'm talking about. Now, to start things off, we're actually going to need to source a sprite. And this is going to lead to one of two issues. And when you look at old tutorials about XNA on the net, or earlier MonoGame tutorials, and they both kind of split with how they do this, you're going to see a lot of stuff that's somewhat outdated in this area. And that's because the way that things were worked has changed slightly. It used to be you could only use the content pipeline in XNA. And then they actually added a couple of workaround methods so you could load images directly. Well, on the flip side, on the MonoGame side of things, there was no content pipeline. At least you had to use XNA Game Studio to make this stuff. So as a workaround for people working in Linux or Mac or whatever, they added convenience functions so that you could load a PNG file, a GIF file, a TGA file, maybe a TGA file, a JPEG, whatever. You could load an image file, a PNG file, dynamically. You could load it from file path. Now, the thing that's happened here is, with the release of the content pipeline on MonoGame, those methods have been deprecated. So the ideal way to get your assets into the system are to use the content pipeline. There are still methods in place for loading things directly, but from the XNA side of things, those functions and functionality is mostly for dynamic images. Things like saving a screenshot. That was the purpose behind them. For loading in performance reasons, for cross-platform portability, for a variety of different reasons, bringing your textures in through the content pipeline is the ideal way to do it. And then at the same time, on the MonoGame side of things, there was these functions for directly loading images, but they existed simply because the content pipeline did not exist. So if you've got no better reason to do it the other way, always try to use the content pipeline for bringing your assets in. Now, if you've been watching this tutorial since the very beginning, you'll have seen me use the content pipeline already. So I'm not going to go into a whole lot of detail, but it's important to what we're covering today. So I am going to still bring our assets in with the content pipeline and show you how to do this. If you need a little bit more detail, either go to the text version of this tutorial or go to the previous ones for the macOS or the Windows-specific version. Both of those covered the content pipeline in a bit more detail. But I'm just going to go ahead and create a brand new project here, and let's get things started. Okay, so the very first thing you do, you've got this content MGCB file in here. This is sort of, well, this is the file, the link to the content pipeline tool. So if I double-click on that, see, I've actually broken this on my computer. You double-click it, it should open up in the content pipeline tool, but I've actually broken it, unfortunately. So I need to actually open it this way. Let me just grab that guy. Where am I? So yeah, don't mess with your file extensions. I actually wanted to be able to read inside of it once, and as a result, I've broken the association, and I'm not actually sure how to fix it. And another thing that's, and I don't like this about the content pipeline tool, and I hope someone will notice this, is I just double-clicked it from the command line, and it's loaded up. Where did it go? Right here. Oh, I'm in it. Just a sec. It's loaded up an old version. Like this is an empty one, and this is the last one I worked on. So that's a bug. Okay, so be careful of that. When you open it up, if you open it from the command line prompt, make sure that it's actually opened up the new version. And generally it doesn't. So I'm just going to go ahead here and open it. So documents. But if you haven't screwed your computer up like I have, generally just double clicking it in Solution Explorer will fix that. Let's see, projects, graphics demo, content, and we'll load it. So as you see, this one's actually empty. So if anyone from the model team is watching, though, be sure that if it's loaded from terminal like this, or sorry, from Explorer like this, that you actually load that one, as opposed to just open up with the previously used version open, because that is very confusing behavior. All right, so anyways, we got this open, and in your world, you generally would have just double-clicked this, and hopefully this opened right away, unless you break it like I did. And this is the content pipeline tool, and this is where we bring our various assets in to be built. And I'm just going to go ahead and add our image asset. This one on my desktop. I'm going to start with the GameFromScratch logo. And I'm actually going to bring in a copy as opposed to linking it, like so. So now our logo is now in the content pipeline. And there's a couple of key settings down here. This color key thing, it's about transparency. We'll talk about that later on. And generally, you should not use this. There's also, you can set it so that it automatically generates maps, which for 3D it's an optimization trick so that you can have different resolutions of texture as you get further away from the camera. Again, to a 2D game, not important. You can also set it for power of 2. Now, as time's gone on, this has become a little bit less important, but a lot of hardware used to require, and earlier versions of OpenGL 1.1, maybe even 2.0, required power of 2 textures. That is 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, etc. in both the width or height. They don't have to both be the same. They don't have to be square textures, but each dimension had to be a power of 2. It's become a little bit less so, but sometimes it's actually still, depending on the hardware you're running on, a good optimization trick to have your hardware, your textures in a power of 2 format. So you can have it automatically resized for you, and you also have some control over how the texture format works. So you down here, you can use directx compression, no change, or normal compression. We'll do none of that for right now. So there is our imported thing. And again, keep in mind, this processor changes. This is the texture importer, but there is several of them, depending on what kind of asset you're bringing in, and then the settings will change according to the asset you're dealing with. So we're taking our image in. We'll use the default settings. One thing to pay attention to for now is notice I set this pre-multiply alpha as true. By default, it was set to true. This will be important later on, so I just want to point out right now in case I forget to come back to it. So this pre-multiply alpha is the default setting. Now head on over to content, and I don't really have to change anything because I'm working on Windows here. But if you're on Mac or Linux, or you're building for iOS or Android, etc., you're gonna have to build for your platform. So just click it, choose it, and then do a build. And then it will result in either, well, ultimately it will be in the directory you specify here or here. So I'm just going to go ahead and do a build. I'll save it, yep. And it's gone ahead and built. Basically what this does, since we only have one, is it's gone ahead and turned this logo .png into an XMB file. So if I drill down here into this folder, so bin Windows, you'll see that we have this XMB file now. That is a binary compile. That is XNA's binary format for assets. So that's our logo encoded to work in XNA, or MonoGame as it stands now. Now on the Windows platform, and this is very important, on the Windows platform, this link to this folder right here from this MGCB file, you can think of it like a soft link. It's automatically maintained for us. So all of the assets within this folder are available to our game. So we come on over here, and just by this being here, by this guy being here right now, it will automatically link to all the various files included. Let's see, it's going to use them from here. It's just a simple script file, to be honest. But we don't actually have to add those files into our content folder. It just works. Now be careful, though, that your content type has the right build action, and the build action is a MonoGame content reference, and this is what links it to that subfolder. So all those files in that subfolder can be used as if they were in this content directory. Now this is important because if you're working on Xamarin Studio, Xamarin Studio. I should find out how that's pronounced. But if you're working on Xamarin, specifically, I know this on Mac, but I assume it's the same case on Windows. I'm sorry, on Linux. That isn't working right now. I know it's under active development, but as of right now, as of today, on June the 22nd, you can't rely on this dependency being automatic. So what that means is you're actually going to have to copy the output into this folder, or vice versa, create a link the other way, and then set each content asset's build property as content for it to work right. So as I said, there's somebody working on this right now, and they say they're very close. So hopefully by the time you've heard this, this is no longer true. But if you're following along this tutorial on Mac or Linux, you may have to copy those XMB files into the content folder manually. Simple enough, just drag and drop that thing, and then right-click, set property to build action to content, and you're good to go. But one of those things to be aware of. So now that we've got our content, we've got that XMB file in here, let's go ahead and use it. So let's open up Game, and let's show you how to load it. Let me just get rid of all the extraneous comments. Alright, I'll pause so you don't have to watch this. Alright, let's just kick over into presentation mode so you can actually see what I'm doing. There we go. Okay, so what we need to do first is to load our content. As we learned from the last episode on the application lifecycle, you should do it in load content. Now, we've got a content manager variable already assigned to our game. Sorry, our game owns a content manager, and that's what this.content is. And the content manager is, predictably enough, responsible for loading the various different types of content. And that's just a matter of load, and then you pass in the type of content. And what we want to load is a texture 2D. Now, for the record, this loader is also capable of loading effect files, models, as in 3D models, sprite font, which is a font version of, a sprite version of a font file, a TTF file that's been converted. Texture, which is the base class for textures, texture 2D, which is what we're using right here, and then texture cube, which is for cube textures. Advanced topic, we'll probably cover it later on. So finally, your only parameter is the file name as the key. Now, the pun not intended. The key thing here is that this is the name we're passing in. You do not use extensions when dealing with the content pipeline or the content manager. So here we just want to pass in the value logo, not logo.png. Now if you use the direct loaders, like texture.load, you do want the extension. But generally you don't want to use the direct loaders. That's what we were talking about earlier on. But in that case where you are loading directly from file, you are using the file extension. But anything done through the content pipeline, no file extensions. Like so. So this will load that, that logo. Now, I guess I should actually do something with it. So let's create a texture, 2D. We'll give it the incredible name of texture. And then here, equals. So it returns whatever type it actually loaded. We're going to go ahead, we're going to need to position it. So vector2 texture position. Alright. So I guess we should actually give that somewhere. I'll do that in here. All right, so that is our position is going to be the top left corner, which I suppose I shall talk about in 1 second. Now let's, oh no, I guess we actually have to display it. So that is loading the file, loading the texture from memory, setting its position to 0, and then finally in our draw here, we have our critical code, our SpriteBatch dot begin. Now this is going to be very important later on, but for right now, just assume it's magic and end. Now SpriteBatch we'll cover in a second, but you need to have one of these to draw in 2D. And basically your draw calls, all of your texture draw calls go within the SpriteBatch. So texture, oops. Draw, and we want to draw our texture at our texture position. And that's it. So what this is going to do is every single draw frame is just going to draw at the top left corner. Like so. And there is our first successful graphic application, other than the square one we did in the last tutorial, I suppose. And then obviously, if we wanted to, um, we can modify the texture position, and it will update accordingly. So we covered update in the last part. Just thought I would show you how the positioning is working there. Now we got a couple of key things to cover here. We're going to come back to the SpriteBatch. It's very important, very key part of what we're covering here. But I want you to understand origins. And this is an area where XNA and MonoGame kind of go against the norm to a degree. It used to be a little bit split, and now this is sort of the prevalent way is not the way that XNA does things. So if you're coming from another game engine, libgdx, Cocos, etc., you might be used to the origin being somewhere other than where it is. And let's talk about that for a sec. The origin is 0, 0. So, you know, let me just show you with my epic paint skills. You've got your Cartesian plane, standard Cartesian plane. I guess I should actually center. Whoa, that's not what I wanted. All right, let's do. Cartesian plane looks something like this, right? So, your y-axis, your x-axis, and then you have your coordinates within. Now, there are two ways of looking at this. OpenGL's approach, 0, 0 is right here. This point going up x, sorry, up y and up x, this is 0 and 0. Now, in directx, which XNA was originally built over, 0, 0 is still here, but instead goes this way and this way. So let's close that down. That means 0, 0 is right here, and 0, comma, your width would be right here, and 0, yes, height, comma, 0 would be right here. Okay, so OpenGL way, bottom left corner. DirectX way, top left corner. And there's some merits to both. As you just saw, mathematically, the Cartesian plane 0, 0 is the bottom left corner, the positive values on a coordinate system. So 1 and 1, etc., are like right. No, that doesn't really show you. Like right here, and then up and up and up. Mathematically, 0, 0 really is the bottom left corner. However, graphically, when you're dealing with pixel units for the way 2D drawing used to work, the way UI still works. So when you say to Windows or Linux or Mac or etc., give me the mouse cursor, it's relative to this spot right here. So both have merit. You don't have to do any funky translations for mouse to world coordinates when dealing with a top left origin. But your math is sometimes going to be reversed from the way that math is expected to be. So again, each has its merits, each has its detriments. Just be aware of it. So 0, 0 in XNA and MonoGame is the top left corner of the screen. So this is 1, 1, 2, 2, 3, 3, as we keep going down to like this point, and this is width and height right here, this point right there. So that is where when we say 0, 0 or whatever coordinate, it's relative to the top left position. And the same thing is true by default with a sprite. Its origin is also its top left corner. So when you're saying something is at 0, 0, you're saying its top left corner is at the top left corner. All right, hopefully that made sense. Let's move on. So now that we've covered that, let's go back to the SpriteBatch for a minute, and let's talk about what exactly it is. And SpriteBatch is basically two things. I guess we can split it into two words, sprite and batch. The batch part is batching or grouping together of draw calls. So one of the big things SpriteBatch does is you do all of these different draw calls to it, and then it generally blips them all out at once. It's an optimization trick. So if you were going to draw each one of these things at a time, that's not how GPUs like to work. So it's going to be slow as hell. So the batching part is a performance thing. It queues them all up and does them at once. Tries to optimize it into as few draw calls as possible and spits it out. So that's the batch part of SpriteBatch. Sprite part is kind of trickier to explain. Here's the thing. XNA and almost every single existing 2D game library right now are not 2D. 2D is not a thing. GPUs have not understood 2D pixel coordinates probably in close to a decade. Maybe not quite that far, but for quite a while now. GPUs just do not do 2D. It's not in their nature. It's not fast. It's not accelerated. It's just not the way things are done. It used to be that way. It used to be that the GPU essentially had a grid of pixels that you had available to you, and then it had a bunch of optimized routines for like copying rectangles here and there. So the optimized unit back then used to actually be the pixels, and you used to kind of work in a grid-like way. Nowadays, you don't do that at all. There is no direct access to pixels on the screen or in the frame buffer or anything like that. It's all fake. The thing is, nowadays, it's all about polygons, texture mapping, etc. It is working in 3 dimensions. Even though you don't know that, you don't feel like that, you are working in 3D. And what SpriteBatch does is makes it so you don't feel that. It's providing a couple things behind the scenes for you. It's presenting basically an orthographic projection so that you have, we'll cover exactly what that means a little bit later on, but it's basically setting up a camera that's 2D-ish to you, and it's creating a textured quad, or sort of four-sided, like basically a square or a rectangle, that is going to be your rendered effect. And that's what we're drawing to. We are drawing in 3D, but we're ignoring one of the Ds. So we're doing 2D, but we're using 3D shapes. It's just all kind of being abstracted away from us. So if you actually looked at what the drawing call did, what the sprite.draw does, behind the scenes it's creating like a quad or a frame buffer, an indexed buffer. It's creating the polygons for you. It's texture mapping them too, and then it's drawing it out to screen. That is behind the scenes for. So that's the other thing SpriteBatch does to us. It basically gives us 2D in a 3D world. So that 2D is being provided by that SpriteBatch for us. Now you can actually do things. You can set the position of the SpriteBatch in 3D. You can have multiple SpriteBatches, and also you cannot use SpriteBatch completely. So if you want to do 2D your own way, you can do all the 3D calls are available to you. You can fake your own 2D if you wish to do so. But SpriteBatch is basically making it easy for you. It is the 2D to 3D, that's the sprite part, and then the batch part is the optimizations. So that's kind of what's going on at the back of things. Let's look a little bit at what SpriteBatch, what draw options we have here. Because right now we're very simply just drawing to the top left corner. Let's mix that up a bit. First thing we're going to do is look at translation. So in XNA, you can actually scale and move. So translation is movement. Scaling is obviously scaling. You can move and position something in one call. That's because you can provide a rectangle. And let me just show you both. So instead of this call right here, we're going to do a SpriteBatch draw, and we'll do this across multiple lines. Now you'll see draw has 8 overrides. So we're going to be playing with a bunch of those right now. And first one I'm going to show you, we're always going to have our texture. Our texture is unchanged, but the vex values that we're going to use is going to change a lot. So you can pass in a destination rectangle, and this is going to be a rectangle on screen representing where to draw it. So not only can you say, so the top left corner of that rectangle is the top left corner. In theory, you'll see why it's not in a minute, but the top left corner of that rectangle provides the position of our sprite when drawn, whereas the bottom right corner represents our scale. So we can do it completely unscaled. So I can do, let's see, destination rectangle is new rectangle. So we could move it to 50 and 50, like so. And texture width plus 50, texture dot height 50, like so. Why are you? Oh, I can't spell. It's like, why do you not like rectangle? All right, so there you go. We're passing in. Why did you have to just be off screen? There. We are passing in destination rectangle as basically move by 50 and keep our original dimensions. And let's go ahead and play that. And you'll see we just translated down 50 pixels, like so. And we've kept our same dimension. But if you wanted to, you could do a resize at the same time. So instead of like maintaining your actual size, make that bottom left corner, say, 250. So we are going to be 200 by 200 pixels at this point, like so. And you see it's scaled down. Or, of course, we don't have to stay square. So there you go. So if you want to not just position, but position and scale, you can pass in this destination rectangle. Now let's look at the next option we've got, and that is rotation. So I'm going to stick with the scaling, but I'm going to, let's see, we'll leave this at 0, 0, but we're going to scale it by half because that source image I'm using is pretty big. Oops. Texture, I can't spell today, sorry about that. Width over 2, texture height over 2. All right. So all this is same thing, top left corner, just half the size. Now we want to add some rotation to it. Rotation is very, very simple, sort of. So we'll do a comma here. I'll add a new named parameter called rotation, and this takes a float, and we will rotate it by -45 degrees. This may not perform exactly how you expect it to. There we are, rotated 45 degrees. Now what's key here is it's 45 degrees about the origin. Now remember I told you by default, XNA draws to the top left corner, and it uses the sprite or the texture's top left corner as its anchor point or origin as well. And you can change that, and that's very critical when you're dealing with rotation, because mostly what you want to do in rotation is actually rotate about its center point. And this is a fairly simple thing to do with XNA. And all we need to do is first close this down and pass in one more value. And you'll see the draw process is very consistent. It's just a matter of you just kind of, the more you need, the more parameters you pass in. So what we are going to do this time is set the origin. And the origin is a vector 2, like so. And the origin is in pixel coordinates of the source image. So texture width over 2, texture dot height 2 is its center point. Let's close that off, and let's run that. And I did something wrong. Just a sec. Oh, yes, I did. Okay, 1 second. Now, changing this origin changes where we rotate relative to, but it has a kind of unintended effect on us here. It also is changing where we're drawing relative to. So, not only are we now rotating about 0, 0, but this translation, this 0 and 0 is the midpoint of our sprite, not the top. And I can show you this very simply by not translating it. Okay, you're not translated now. Oh, actually, that's exactly what I'm showing you. So we go back to running it. Are you it or are you the pipeline? Okay, let's run it. And you'll see we're actually now 0, 0 is the midpoint of our sprite. You see? So now what you have to do is take into account that width and height. So you actually have to add these two values to the position. Like so. So I hope that made sense. So that when you make an origin change, you're not only changing where you're going to rotate relative to, you're also changing where you're translating relative to. So, oh, I need dots. Let's throw some dots in here, like so. So now it will probably be positioned where we want it to be. It's not positioned where I want it to be. Ah, God. Okay. Another effect being demonstrated here. This isn't the case either because we've actually scaling it in half, right? So we use the dimensions of the unmodified version, like so. So quick workaround for this would be here. So not only do we have to take into account when we're doing our translation here, we don't have to just take into account the fact that our origin changes to the middle of our sprite. We also have to take into account that we're resizing our sprite by half. So now this will run and be translated as we expected at the same time. So I could have shown you that without doing the scaling. Let me just do that. So instead of scaling, make this thing a little bit simpler. So 0, 0, texture.width, texture height. All right. So full size at the origin, and you'll see it's centered about the origin. See, because that's because we've moved the origin with this call right here. So now we need to take into account that movement by adding these two values to our translation. So you and you, like so. And now this will put us back where we were. Now, what you saw earlier, though, is because I was doing a scale, that's even less accurate, right? So you have to take into account, you move the origin, you change the size. So when you're doing your translation, you have to do it relative to the new scaled size and the new origin. So these things all kind of interact together. Very important to understand that, as you just saw me mangle. Okay, so that's the final thing we are going to be looking at. I believe it's the final thing. No, second from final is tinting. And you can also apply a color tint to your draw call, and I shall do that right here. And it is just simply by setting the color value, and it takes a color. I'll use a predefined one, color.red, and this is just going to apply a red tint to every pixel in the resulting texture, like so. And now what you're seeing is this underlying image was blue, and when you add red to it, you're ultimately turning it into black. That's why the results are the way they are. And as you can see, that is only applying to the texture itself, not the cornflower blue area being drawn in the background. But so you can quickly tint color onto your texture using the color parameter here. And then finally, you have effects, and there's really only 2 effects, I believe, that are defined. And they're flip horizontally and flip vertically. And if you want, you can use them together. So let's flip this image horizontally and vertically. So we're going to do both of them at the same time. And oh, I'm rotating as well. Okay, that's kind of confusing. Let's take the rotation out. That does get a bit confusing. All right, let's do that again. So flipped horizontally and vertically, as you can see. So those are the basic parameters you could do while dealing with draw. It's mostly what you want to do. You're basically your scaling, your rotation, your translation are all in there. Those are your biggies. Flipping is actually surprisingly common, so it's nice that that's built right in there. The tinting, probably not going to be used too often, but it is available. Now there is one thing we didn't touch, that's layering. We'll touch on that in a second. So, but that's basically, those are the options available to draw. Now let's look a little bit closer at the SpriteBatch itself. The other big thing that SpriteBatching does is provide sprite blending and blending, pretty much blending. So let's get into that example right now. And this is important. Where sprite blending comes into effect is basically when you draw 2 sprites over top of each other that have transparency information. How is that transparency handled? And that's sprite blending. And this is one of those topics where you can get really deep into it or ignore it completely. If you choose to ignore it completely, you can just go, works like magic, great, there you go. Because the default option now, as of XNA 4 and what MonoGame implements, the default option is probably, in your world, the easiest option. And they changed the way things worked. They used to use interpolation, pixel interpolation. So if you had 2 source images, generally they have an image that has transparency. There is one of 2 ways they used to do transparency. There was encoding it right into the image data. So what you have is RGBA, or red, green, blue, alpha, where the alpha determines the amount of transparency that there is. So full alpha is full opaque. Actually, I might have screwing that up. Anyway, full value versus 0 value goes from fully transparent to fully opaque. Whereas you also had a common concept. Remember back in the content pipeline, there was this thing called color key, or it's also referred to as chroma key. And if you've ever seen a behind-the-scenes movie making kind of documentary, you've heard of green screening. And the whole idea behind green screening basically is they shoot someone in front of a color they're not going to use. So that way a computer can come along and say, okay, everything that's green in the background, let's get rid of it. And essentially that's how you can do color key transparency encoding. Now there are some advantages to this approach in that your file size doesn't get any bigger. You don't need a dedicated channel of information for transparency. When you think about it, an RGBA setting, let's say, for example, we were, and you've probably seen this before. I don't know if I can get an easy example up in front of me. No, it's not an option here. There are dozens and dozens and dozens of ways that images are encoded. And those, you'll often see something like RGB 4444 or RGB 8888. And what that's saying is basically there's an RGBA channels, so red, green, blue, alpha channel, and each one is 8 bits in size. So if you have an RGB value that's 8 bits a piece, you have 256 values of red, 256 values of blue, 256 values of green, and 256 values of alpha. Now that in turn is going to take up 32 bytes per pixel, right? So 8 plus 8 plus 8 plus 8, you got your 32 bytes per pixel. Whereas if you're doing it with chroma key and embedding it, you only need your red, your green, and your blue channels, so you only need the 24 bits per pixel. So you can save a quarter of the file size by just using that bit encoding. Now the reality is, for most of us, it doesn't matter. Like, file sizes are not that constrained anymore, and you're running everything through the content pipeline that can take care of the stuff for you. So that left you transparency encoding. So if you're dealing with one of the image formats that supports transparency, which basically boils down to PNG supports transparency all the time. JPEG can, but generally doesn't. GIF nobody uses for games. For the most part, it's patent encumbered and a bad choice. Bitmap has never got a transparency channel. PCX does not. Target does, but isn't very often used. So different formats do or do not encode it, or optionally encode it. So you can have a JPEG that does or doesn't encode it, potentially. So your different file formats either did or did not support this transparency layer. And mostly it boils down to, you just have to pick a format that works. And in this day and age, PNG is a good choice. It's got a nice file size. It supports an alpha channel. It's well supported in tools. It's a good choice that way. You can have a very, 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 very small amount of degradation because of the compression you use to store a PNG. But for the most part, the the trade-offs are solid. It's fast enough. You can load it fairly quickly, so it's a fairly fast format to decode. The file size is decent. The storage size is decent. It's got alpha channel information, etc. So the answer is basically just use a ping. And now what happened, or what used to happen when people used PNG encoded things, is you kind of run into, and I'm going to screw this up, and it's hard to explain until you've experienced it firsthand, but you could get graphical artifacts when you had two PNG channels competing with each other. So if you had close to zero values, close to 0 and 0 are very different things when you're dealing with graphics. And what it could end up with is your outside edges with these two transparent overlays would result in visible artifacts around the edge. And you Google online XNA for border around my image. Why is XNA rendering weird pixels, etc.? And that's this bleeding effect that could exist from having alpha channel additives. So what they basically did is, as things were layered on top of each other, their alpha channel values were sort of added up. And like I said, sometimes 0 wasn't 0, and it resulted in these weird values. So what they've done with, and if we go way back to the mono pipeline, when I said this pre-multiplied alpha is true, well, what XNA essentially does is turns the alpha channel into a completely separate value, and it's a value that goes from 0 to 1. So what that solves is, if every image has this transparency value, so let's say I'm 50% transparent, I'll have a value of 0.5. And instead of having, 250, instead of it being part of my color makeup, it's a completely separate value for transparency only. And then every other one's additive. So if I'm on top of 1.0, I can't become a 1.5. It just becomes fully opaque and it's done. And that's what this pre-multiplied alpha does. And by default, it is the default blending mode. So when you import your assets into the XNA content pipeline, it is automatically generating this pre-multiplied alpha for you. And this pre-multiplied alpha does not have the rendering artifacts that interpolated transparency can. So if you're going to just load your images directly, you're not going to use the content pipeline, or you're going to turn this off, which you can do for some reason. I don't really know why you would, to be honest, unless you really needed to save file size, potentially, I suppose. You can turn this off, but as long as you don't, transparency is just not a problem you need to worry about. The Sprite Blend's default modes and this parameter right here will make it just work. So leave it alone and you'll be a happy camper and you won't get these weird artifacts. But if you do need to save down size, you could switch back to the interpolated mode. We'll show you how in a bit. Or if you really want to, you can go back to this chroma key mode. And the only reason why you would ever do this, I think, is because you need to save that byte. 1 byte per pixel image. So if you have, I don't know, You can save a megabyte from texture sizes for not having that value in. Now, a lot of times that you're not going to be that tight on space. It's not going to be that much of an advantage. And you won't run into the oddities. Because if you use a chroma key value, it means you cannot use that color value in any of your blended images. So it has to be reserved. I just think it adds an element of annoyances to it. Plus, it makes your texture sheets look ugly as hell because you normally have a pink or a green background that they're drawn over top of. But if you really want to go to that approach, this is where that's set. Set it right here. That's the color. You're setting the color that's being used as. So in this case, it's using. Why is my color theory so crap? Full. What is full red and full blue? Yellow, blue, make green. I don't know. Whatever color full red, full blue, no green makes is what they're using as a color key value. But you do not generally use that. So stick to this pre-multiplied alpha, and transparency is just not going to be an issue for you. So that's the lesson of the day. And now to actually illustrate this, I need a texture that actually has transparency encoding in it. And you can tell that, let's see, here's one right here. And I'll open up my image editor. And you can see it's got it because this nice little checkerboard in the background is showing you the result. And I can illustrate this nicely by creating a layer here. So let's duplicate it. Go back to our first layer. We'll select everything, and we'll go to our second layer, and we will paste another version of it. So we now have two of them, and they're overlaid. So this is transparency, and this checkerboard in the background, this absence of color, that is your alpha channel. So if your graphic, so if you're working with the BMP, this can't happen. It will just simply overwrite the other image. So this image has the transparency information that we need. Let's go ahead and import it into our project. Let's close that down right here. Oops, right here. So edit, add existing image. That was on my desktop. And transparent sprite, pun not intended. Oh, actually pun fully intended. And again, kick with the default. You're good there. I don't know why chroma key is on by default. That doesn't make any sense. But anyways, just make sure this pre-multiply alpha is on. Let's go ahead and build that. Yeah, sure. Save our project and build. So it's now encoded both of those files in. Let's head on back to our code. And so now we need another texture. Creatively named texture 2. And it was called transparent sprite. No extension. And let's drop us another 2 here. All right, let's draw our first texture. Like so. And our second texture. Perhaps I should actually put the draw call in there. Like so. All right, so we now have two textures, one with transparency. And now keep in mind, I told you that that whole default value for SpriteBatch begin is compatible with this pre-multiplied alpha. So we don't really actually even have to do anything, and we just get transparencies. It just works. So there you go. There is our one texture being drawn over top of the other texture. Now let me show you something very important here. This bottom texture does not have any transparency. It's 100% opaque. And this is another thing that's critical to know. Let me just show you something here. Let's grab that guy and draw it first. What's happening here? Well, the problem is your draw order is the same as your draw order. And you think about this like stacking a set of plates. When you go to a cafeteria or whatever, and they have the plate tray at the end, the first one you draw goes in first. And then your next one, and your next one, and your next one, and your next one. So here's your first one, and that's our transparent sprite. So it's on the very bottom. Now we've got our next draw call, this guy, and it's done on top of it. So now, because there's no opacity in this it's 100% opaque, it's overwriting this texture entirely. So the order that you specify your textures right here is very important, but it can also be controlled. And a lot like how we had our different draws, what we pass into begin is very important to this. And the next thing we're going to do is we're going to set the sort order, or sort mode. And sort mode, in this case, we've got a bunch of options, but let's go from, oh, and the default option is a deferred. And what deferred means is do all your draw calls, like I said, sort of like the stacking of plates, all of those draws happen, and then when you press end, it just figures them out. And so that means basically the default deferred order means draw order. So whatever order you drew them in, it will do. And now another one that you should be aware of, and this used to be very important, and it isn't now. So when you deal with old tutorials, you will see them using this mode. And for the most part, 99.9% of the time, you never want to use this mode. It used to be you could only get certain special effects by using this mode. And that's not the case anymore. There are ways to do those effects within the SpriteBatch. So those are not good reasons to do it anymore. But there used to be this mode, and there still is this mode called immediate. It says sprite mode. Sort mode dot immediate. Now immediate says draw when this is encountered. So your sprite batch is not a sprite batch. It's a list of sprites, and each time you call draw, it immediately draws. Spits out a GPU call. Draw this. Now draw this. Now draw this. Now draw this. Now draw this. And the performance of that sucks badly. So if you use this mode, if you use this immediate mode, you will get crap performance. So by default, unless you've got a good reason otherwise, stick to deferred. And there's also this texture. Texture is kind of interesting. Basically, it sorts them by texture and then treats it just like deferred. So basically, orders by texture and then ordered by draw call. And what that allows you to do is put a bunch of calls from the same source texture in the same layer as an optimization trick. It's kind of not going to be something you're going to deal with today, but where it would be useful is if you're drawing from sprite sheets on one level. So if you're drawing your entire background from one sprite sheet, all on the same texture, doing it as texture is handy in that case because it will automatically do the sort by textures as well. A bit of a performance trick. Now ultimately what you want to try to do is keep the draw calls to as minimum as possible. And the best ways to do that is by having all of your sources be on the same texture if possible. We'll talk about sprite batches, as they're known in different, okay, that's a confusing thing here. Texture atlases or sprite sheets. They're the same thing, and it's something that we'll talk about down the road, but it's a very simple concept. It's just a matter of putting a whole lot of the same stuff in the same texture, so you make multiple sprites out of a single texture, and it's an optimization trick, and that's where this texture value comes in very handy, but we'll talk about that a little bit down the road. Okay, so by default, it's this deferred, which basically means you draw in the order that it comes, and then at the very end, when it hits this end call, it draws it again in the order you specified. Now, if you want to switch that up, you can switch it to back to front, like so, and let's run that. And then it's basically my analogy of stacking plates on top of each other just got flipped on its ear. So now, it's drawing the back image first, and then, drawing the back or the bottommost plate is being drawn first, and vice versa. So we can also flip that around. I don't know. I'm trying to think right now, immediately offhand, why you would use too much front to back, or why the hell did you do that? That's not what I was expecting. I don't specifically know why you would use front to back or back to front, or anyways. I don't know why it's not changing anything. Might be because they're on the same texture. Okay, so ignore that one anyways. Those are two values that generally won't use as it is. You basically always will going to want to keep it at the default, which is, once again, deferred. And we'll leave it at deferred, unless, of course, you're dealing with, again, a whole bunch of textures being on the same texture sheet, or a whole bunch of sprites being on the same texture, in which case texture can be a bit of an optimization trick. Let's just go back to the complete defaults for sort mode. I just want you to be aware, the biggest thing to take away from this is you're going to have a bunch of old tutorials that said use immediate. And the reason why they used to use immediate was because it allowed you to make alterations in between each call. So it was used for certain special effects, etc. But the way that the underlying rendering worked behind the scenes in XNA4 was changed. So that is no longer required, nor is it efficient. So the most efficient way is the default way. So even if you're reading an old tutorial, ignore what they're saying. You want to stick with the default sort mode, which is deferred. And again, deferred just basically takes it in the order that they're drawn, and then when this end call does, it optimizes them as best as possible and does it as few draw calls as possible in the order that you specified. Now, it's going to be sometimes you're not going to want oh, I know why front to back didn't work, because I didn't define them. Damn it. Okay, sorry. Ignore what I was saying about front to back or back to front, because I didn't actually tell them where these things are ordered. Now, occasionally you're going to have it where you want to say, this guy is always at the back. This one is always at the front. So, for example, let's say you have a fixed position thing like a HUD. That's always going to be your topmost layer. And then you have like a parallax background, which is always going to be your backmost layer. That's where your front to back and your back to front sorting comes in, where you're going to, instead of drawing them in order, you're going to actually specify or tell XNA how you want it to do it. And that is in your draw call again. Remember I told you there was one parameter we didn't touch on that we will later, and that is the depth. There's a parameter called layer depth. And what you're allowed to do here is basically, I'm going to go ahead and say, this is layer, all right, what is texture 2? Texture 2 is our sprite logo. So it's layer 2. And this one is layer 1. So I've got, draw this at the back, this at the front. Assuming, of course, I have sprite sort mode, front to back set. Go ahead and render that, and you will see the end result. Okay, so now I can change the, actually, sorry, we want back to front. Okay, now I'm going to go ahead and say that our, man, why the hell are you doing this to me? Okay, 1 second. Alright, sorry for the confusion. My problem here is this is a normalized value. I was thinking it wasn't. So your layer depth is any value from 0 to 1, not 1 to 256. I got them mixed up in my head. So when you're layering, the back is 0, the front is 1. So if you want to do front to back and you want this texture to be the frontmost, make it a 1. This one, make it a 0. So this is your backmost possible layer, this is your frontmost possible layer, and this is saying sort from front to the back. So now go ahead and run this, and we'll see that result. So if you need to manually specify the Z order, or how things are drawn on top of each other, you can use either this back to front or the front to back sorting, and then this layer depth value. And again, frontmost, backmost. So if you get this situation here, so I can go 0.5, so you can do very, very, very granular levels of control. And then 0.4. This is going to have the exact same effect because 5 is still in front of 4. Whereas if I flipped it so that it was the other way around, so that this was lower, then this will actually be the texture drawn in front of it. Like so. So sorry about that. That was where I was going wrong. It's a value from 0 to 1, not 1 to 256. So it's that infinite level of it, and this you would only really use it. It works just like defer, but you are overriding it essentially. Where if you have this layer specified, this will, you can say as much in front or as far behind, and you can switch the logic around completely by making that back to front instead of front to back. But 1.0 is fully front, 0.0 is fully back, and you can be anywhere in between as you go. Now, I mentioned previously how you don't need to use the pre-multiplied alpha if you don't want to. And that is actually set, again, as a parameter to calling begin, using a parameter called blend state. So we look at it here, and it's called blend state. And your default value is your alpha blend, and that's going to go ahead and use the pre-multiplied version. Now, if you want the interpreted value, so if you're using raw PNG files, for example, you're not using the content pipeline, or you're not creating a pre-multiplied alpha for whatever reason, then what you do is you just come on in here and set this to non-pre-multiplied. If, on the other hand, you don't have an alpha channel at all, or you're going to be drawing 100% over to basically just want to do a raw dump. And it's going to be somewhat rare, but it's possible that sometimes you have an entirely opaque set of things to draw, or you don't have layers to draw upon, in which case you can set it to opaque, which will be slightly faster in those particular cases, because there will be no blending at all. And finally, you can do additive. Additive is not going to be very useful very often, except for potentially special effects, and that's just basically going to add the pixels to the pixels that are below. So it'll create a combined color based off of the differing layers as you've got them. So slightly red to a white will come out with like a pinkish hue, for example. And I've gone way longer than I intended to here, so I apologize. I'll probably wind it up right now. There's a lot more that you can do here. There's like things like depth and stencil buffers that we're not touching on with begin. We'll talk about advanced graphics that you could do with a SpriteBatch later on down the road. But for now, just be aware about the sort order and the blend state. The blend state, actually, you don't even really need to be that aware of. As long as you stick with the defaults, use your pre-multiplied alpha, and use an image source that has an alpha channel available, none of that matters to you. So then you can just come and use the defaults, draw them in the order that you want them to be. Otherwise, use this layer depth to manually define what order you want things to draw in, and you're good to go. Hope you enjoyed that. Thank you very much. Bye.